Okay, this problem says in the diagram AB and AC, sorry I missed C, are tangents to the circle centre 0 with a radius 3.6 centimeters. Calculate the area of the shaded region, this bit, given that this angle is 2/3 pi. Okay, so the first bit of information in that text told us that BC and CA were tangent to this circle, which 0 is the centre. That bit of information there, because we know if that's centre and that's touching there as a radius, then where these meet must be a right angle. Okay, so we've got a kite. To make this problem a little easier, I'm going to split it up into two triangles. Now we're very comfortable with the area of triangles, and if I work out the area of both of those triangles, all I need to do is minus from that the area of this sector. If I do that, I find the area of the shaded region. So that's the plan. Okay, so the first part of finding the area of these triangles is making sure we have all the information needed. Now, because these were both a radius, we've got two lengths and an area, and an angle, which allows us to work out the area of this triangle here. However, the other triangle, we only have one bit of information. Well, that one bit of information is this angle here. We know that for a four-sided shape, the interior angles must add to 2 pi, or 360 degrees. So if we've got pi over 2, and 2 over 3 pi, this must be pi over 3. Okay, and we're going to try and figure out the other two angles. This gives us a little bit extra information if we do, but please know that this length and this length are the same length. But if we knew those lengths, we'd be able to do something with it. Currently we don't. So what we're going to do instead is have a look at this angle. Well, we know that this angle, and this angle add to pi, and that the other two that I don't know must be equal. So there's only 1/3 of a pi left, so there must be half of that, so each one of these angles is pi over 6. Same for the one at the top. For them to add together to give me pi over 2, that leaves this being, lo and behold, pi over 3. And same for this top one. That means you've got an equilateral triangle, because all the angles are the same and the lengths are all the same. Problem is we still don't have the length of one of the sides. However, since the other triangle has two lengths and an angle, we can use that to find the length of the other side using the cosine rule. So that's what I'm going to do first. I'm going to call this length here x. So x squared is equal to 3.6 squared plus 3.6 squared minus 2 lots of, well, 3.6 squared times there, of the cosine of 2 over 3 pi. Oh, I've gone off screen. Okay, as it turns out, the cosine of 2 over 3 pi is minus a half, so that becomes plus 1. So we've got 3.6 squared plus 3.6 squared plus 3.6 squared. So 3 lots of 3.6 squared. Find the square root of that, and it turns out that it is 18 root 3 over 5. A bit of calculator work. Okay, so we've got the length of one of the sides now. So now I can find the area of both of the triangles. Okay, so this is the simplified situation that we have at the moment. We've got these two lengths here being the same, and these two lengths here also being the same. Guess I could just do this. Donate that. So what I'm going to do now is find the area of these two triangles. So the equation is a half times by the two lengths times together, so it's half of 3.6 squared, times by the sine of the angle between them. So that's for this triangle. Added to that is the area of this triangle. So same idea. We have half times, a little more complicated here, sorry, 18 root 3 over 5 squared, run out of room, sine of pi over 3. So if you type that in your calculator, you end up getting something along the lines of roughly 22 centimeters squared. Okay, don't round it up now, save that in your calculator as whatever it is. Okay, so final step, I've worked out the area of the whole blue shape. I want the area of the yellow shape, so all I need to do is minus off the area of this red sector here. Now, the equation for a sector is very simply a half r squared theta. So it's a half times 3.6 squared, that was the radius of this, times by 2/3 pi. That should give you something roughly equal to 13.57. Now, good sign, this number's smaller than the number we got for the whole thing. Tells us we're on the right lines. Finally, subtracting the 22 point something from before, from 13.57, we end up with an answer of 8.88. Remember the units, centimeter squared.